let me proceed with the presentation. Uh, BIM is generally people used to tell when we ask what is BIM, people used to answer building information modeling, and also they think the B in the BIM stands for building is a noun which signifies a building or a construction as a infrastructure, but actually the building here is not a noun. It signifies a verb. It is building an infrastructure model. It is like we are building an like information model. Sorry, it is an information model. So building an information model refers to BAM. This is just information model is the core aspect of BIM, a model which contains all the information about the building, or about not only building, about all the infrastructures like walls, fans, ceilings, columns, beams, etc. They not only includes the building, it includes all electrical, mechanical, and all the fittings. That is why it is called building information modeling, and it's not that building word is not a noun, it is a verb. And to, to go with the flow of the presentation, I would start with as many people know about BIM. I would just give I would just hop on with a small introduction about BIM, where you will get to know the awareness of BIM, and then we will show like I will show some of the applications of BIM in water infrastructure, and later some case studies, followed by it will be the most interesting part of the presentation is the BIM and GIS integration, integrating two platforms together, and then we will be seeing some case studies on BIM GIS integration, and with that I will conclude the presentation. So to BIM or not to BIM, this question arises for all the contractors, whether we should go with the BIM or we can go without BIM, can we execute the project or not. Actually this starting 4 to 5 slides give you the answer whether you should go with the BIM or not. You can proceed with the conventional methods. Why BIM? BIM actually there before the invention, like before the starting of BIM, people used to construct buildings with 2D drawings, and before that even they were constructing buildings just by visually, and giving all those structures remain resilient, and they are still, there are many thousands of years before there was no BIM, even then they have constructed buildings, and those are still resilient and standing tall. So why BIM is necessary now? Why can't we go with the conventional method? So here BIM actually is a process where the starting to ending of whole process of the construction life cycle, you can use the BIM here. So here BIM refers to a process where you are starting with the conceptual design. Even before conceptual design, you are starting with the employee information recording for all the programming, and then you will go with the conceptual design, and then it also goes with the detailed design, and then analyzing the design and conforming the documents and submitting into client for approval. And later you are using BIM for fabrication and construction, and during the construction phase for fabrication of steel structures and everything, and during the construction phase you are using it for scheduling and also cost estimation and various other reasons, even site logistics, etc., construction logistics, and all this are used in construction stage. And then later we are using BIM in operation and maintenance also, um, where the lightings, ventilation, everything is measured, and that and based on even the sensors give the readings of the security system and everything. That is where BIM is used in operation and maintenance also. Later in operation and maintenance, it also goes to renovation. When the buildings take after a few years, 10 to 30 years, you will go for renovation. Only when the complete documentation is available, the renovation will be easy. So, and even if it go for demolition also, you should plan the demolition. There also we need a model where all the information is available. Hence the information flows from programming, conceptual design to entire life cycle, to the entire process. The information flows. That is why BIM is defined like BIM is a process more than BIM as a tool. You have to consider BIM as a process. only then the information can be passed through whole the model, and the fruit and the whole fruitfulness of the BIM can be achieved. Also, I would like to annotate that BIM is a technology and it is not a software tool. Most of the people who know BIM, they think that BIM is a software tool where you are building it into a 3D model and then utilizing it for construction. But BIM is a technology. It includes many 3D models, 4D models, 5D models, construction logistics, everything. That is why here you can see it is used in all the applications. So it is not a software tool where you are using Revit. Revit is a software where you are using to construct a 3D model, but there are various other softwares for other applications also. And all this combined together is a technology, and that technology is called building information modeling. Here, the information flows through entire life cycle. And to start with, what are the common problems in construction? Mostly the construction site, there are productivity issues, there will be some safety issues, or some so that's what, like time, cost, safety, and quality issues. These four are the main construction problems faced in a construction site. The time here refers to the productivity issues, and also the scheduling issues, where you cannot like you will be scheduling an activity in and flow, but whereas due to the inefficiency or due to the unavailability of equipments or manpower, it may be disrupted. So here time will be an issue where you are not completing the project on time. And also the cost is like you are generating the bill of quantities and estimating the cost, but whether how come, like how far you can give assurance that the cost you have estimated is absolutely 100% correct or not. So here the cost will also vary, and also based on the site parameters, you will there will be revisions in drawings and revisions in excavation quantity and those things. There also cost will vary. And safety is the foremost in the construction industry, where all the safety precautions should be taken before starting the activity. But due to negligence of the people, safety has not been considered in most of the construction sites, and due to the economic factors also. But whereas BIM can ensure safety at a site, that is how like giving providing the barricades and everything can be modeled in BIM. And for free fall from height also, you can model all the net and safety nets and required things in BIM, and that can be showcased to the client, and that will be executed in the project site. That is how safety is also linked with BIM. And also quality of the materials, the BIM model will provide all the specifications of the materials which is required, how to build the for a base, for particularly a beam or a column, what is the mixed design, what is the steel reinforcement to be used, everything will be more provided in the BIM model. And that is how quality is also ensured. Other problems is like flow of data where you are there are multiple stakeholders involved here, civil, electrical, mechanical, and all the teams are involved here. They have to collaborate each other, and the data have to flow from one to another in a perfect manner, so that that's not any that there will not be any miscommunication, or there will not be any missing of data. That is, the flow of data is also a problem in norm in a conventional method. And scheduling of work, in conventional method the work is not scheduled. It is like just like that, based on our experience, you will schedule the work, you will go with the work, you will start with for excavation, footing, and like that. But in between there are many clashes which will occur. So proper scheduling of work is a problem. And also bill of quantities and cost estimation is not accurate. And digitalization of data, all the data will in the conventional method will be in paper and pencils, and like paper and pen, and those will not be converted into digitalization when BIM is not utilized. And also class deduction. See here, mechanical people will be designing a pipeline duct here, and electrical people will be designing an wire duct here. So both the ducts will clash together when they are when a normal model, like when it is followed through conventional method, he will be submitting a drawing separately and electrical will be submitting a drawing separately. And when you are during the construction only, people will realize that there is a clash between the electrical and mechanical pipe ducts here. But whereas in BIM model, you can identify the clash very first itself, and you can avoid the clashes, or you can check for clash detection. And why is it BIM, why is it important in this is why is it important in contractors perspective? In contractors perspective, nowadays client is mandating BIM, including all the government clients, private clients, everyone is mandating BIM. Only all the projects nowadays are BIM mandated. And before, there was a market barrier, like where the AutoCAD was more specifically used, and
Mm.
BIM was so costly. But now BIM has become cost efficient, and you can use the BIM, and there is a return of investment in when used in when BIM is utilized also. And then international, region, national standards. Before, there was no standard practices, there is no standard for BIM. But whereas now, ISO 19650 is an standard for all the BIM processes, and it has been released till part 6 also. So now there is a standardization of BIM practices. So that is why we have to implement the like contractors, client, and everyone are more focusing, or more particularly asking the contractors to go with BIM models, and complete the project with BIM. And cost optimization. As I have told you, during the design stage itself, you can see for different options, and you can go for optimization of cost, and remaining competitive in the market, where conventional method is it takes huge time and also huge cost. This BIM will keep you ahead of time, and will keep you ahead of other competitors, and where the time and cost is reduced compared to others. And there are also minimize of waste. That is also an important aspect of BIM. And coming to dimensions, there are almost 10 dimensions in BIM. But whereas in Indian perspective, we are only using till 5D BIM. Many projects are only utilizing till 5D BIM. But actually, there are 10 dimensions which has been defined till now. 3D refers to all the models, where all the animations, renderings, BIM walkthroughs, everything is done in 3D. And 4D refers to the scheduling, where the lean schedule, and also the how the project has got to go through, like project has to be constructed, everything, all the scheduling will be done in 4D. And 5D comes for cost estimation, like estimating of the quantities, and then estimating the cost, real time conceptual modeling, like all the cost estimates of mechanical, civil, electrical, everything, and MEP systems, everything will be coming under the 5D BIM. So then later, 6D and 7D are very rarely, some of the projects in Indian perspective use 6D and 7D. 6D refers to sustainability, and where lead tracking and all the lead certifications involve 6D. And 7D goes for facility management applications, where the as-built data of the buildings is collected in a COBie data format, and then it is used for facility management, like lighting, ventilation, etc. And now we will hop on to level of development. There are different level of developments, where LOD 100, LOD 200, 300, and 400 and 500 are specifically used here. And there is another level of development called LOD 350, which is between LOD 300 and 400. LOD 100 is a conceptual model, where only a simple model, example first, you can see here, this will be the as-built model, but for that, just a small box diagram is called a conceptual model. How this will look very basic details about the width, height, everything, and that will also be only approximate and not precise. That is what called a conceptual model. And then comes LOD 200, the development a little bit more developed compared to LOD 100 is called LOD 200, and it refers to approximate geometry, where very approximate quantities, size, shape, and everything will be developed here. And then comes the precise geometry, which is LOD 300. Here all the sizes and location, quantity, everything will be precise and accurate. That is why this LOD 300 mostly you can use it for construction, whereas an upgraded version of LOD 300 is LOD 350, where some more details. Example, in a beam, the length and width and depth and length and width of the beam will be given in LOD 300, whereas in LOD 350 all the reinforcement details will be provided, and in LOD 400 all the double bars and all these details will be provided in LOD 400. That is how it will be developed stage by stage. LOD 300 just gives the width and breadth, whereas LOD 350 gives the reinforcement details, and LOD 400 gives each and every double bars and even the tie rods and everything, all the details will be given in LOD 400. This is used for fabrication, and it is used for construction, which is an gives the accurate details of all, including the assembly, installation, everything. Even for an equipment, even the installation details will be given in LOD 400 only. Once the construction is completed, all the field data is verified into to the accurate size, shape, and location into the LOD 500 model. That is the as-built model. So for now, BIM hardwares and softwares. Most of the people think when it comes to BIM, most of the people think that BIM is and Revit. BIM, Revit are both synonyms. That is what most of the people think. But actually, it is an BIM. Revit is an Autodesk product, and that is used for creating 3D model only. But whereas for all the other applications of BIM, we have to go for different softwares. So here are some of the softwares which we are using for conceptual design and analysis. That is what building 3D models. You are using Tekla, Bentley, SketchUp, and etc. And for 4D and 5D, you are using for Synchro, Navisworks, and etc. And for 5D, we are using Costex, Assemble, and Deep Profiler, etc. And then for collaboration, where you are checking for clash detection, we are using Autodesk, Navisworks, BIM Collab, etc. And for visualization, you'll be using Twinmotion, and the Enscape, Iris VR, and these are used for VR and AR applications. And for BIM collaboration, you will be using BIM, Autodesk, Tekla, and Trimble Connect, etc. These are some of the hardwares and softwares used in BIM. Coming to application, there are numerous applications for BIM, whereas some of those applications are listed here. Starting with the 3D integrated engineering, where the models are provided in 3D and it is hosted in 3D, and you can view the model in 3D and proceed for construction. And this multidiscipline models are integrated into one platform. That is why it is an integrated model. And then coming to schedules and quantities, and BOQs and schedules extracted from BIM models are also one of the application of BIM, where you are extracting the BOQ and schedules for all the schedules for Navisworks and everything. And then comes the coordination. Autodesk Construction Cloud and some the cloud-based coordination softwares are available for reviewing all the models from the starting to the ending till the submission. Everything, BIM will be a common platform for coordination and review. And then clash detection and avoidance. Clash detection is as I have explained before. Clash detection is when you are when the multiple discipline works together, mechanical, electrical, and various discipline work together, and the models will be developed separate by different individuals. So when they have to be integrated in one platform and check for whether there is a clash between each and everything. And construction planning also for scheduling all this, and progress monitoring. I will show you next slide, and asset information. And for automation, like this is a most recent and most widely used application of BIM, where all the artificial intelligence tools and everything and for machine learning is utilized for BIM application for automation of different construction activities and different review activities. And some of the applications here I will explain in detail. Progress monitoring, and this is one of our project, Parvati project, where you can see the site status as on 6th March. So all this shows you the site status as on 6th March, how much as per the schedule which we have provided. The BIM model will show how much you have to be you have to be completed, and like how much what will be the status on site as per this date. That is what showed here. And see here, this is as per 17/7/2021, the actual progress at site and actual progress in BIM. In BIM model, you provided the schedule for a 4D schedule, Navisworks schedule, where the actual progress as per this date has been extracted separately. And you can see that how site has developed to this date, and how the model will show how much should be developed till this stage, and whether you can check whether all the activities are completed or not. Similarly, for another pump house, the same actual project at site and actual project progress in BIM. And this is a 4D model. Um, okay, the video is not playing. Okay, anyway, this is a for demonstration of like a 4D model, where all the early appearance, on schedule, late appearance, everything will be showed here. And class deduction, for class deduction, I have explained you earlier about class deduction. That is, this is a Naviso page where all the class deduction are showed here. And there are three types of class: hard class, soft class, and 4D workflow class. And hard class is nothing but, for example, mechanical duct and electrical duct, which clashes together, like which is rooted at the same place location, clashes together, is called an hard clash. But whereas soft clash is something like you are modeling a column exactly behind the door, and that will not be showcased in the model. Like when you are going for running the classification, only hard classes will be shown in the model, like will be taken out and shown in the model. But whereas soft classes you have to identify individually. For example, a door is a column which is placed just behind the door. Then you can then there will be no provision to open the door. That is how. But in the in the model, it will show there is no clash. But these kinds of clash are called soft clash, where it will not be shown in model, but you have to check for various reasons. And in, for example, in a pump house, the pumps will be located underground, like in the sump region. But when during the maintenance period, the pump has to be risen to the top level, and it has to be transferred for maintenance. There has to be sufficient clearance to lift the pump, because pumps are not small structures, that are the small equipments, that are huge equipments. It will be of almost 2 meter to 3 meter height. So that much of clearance has to be provided in the pump house, so that it will take some activities has to be taken in an
Sir, your voice is breaking. Sir,
in the flow only, like flow, you will be, it will be like, again you have have to dig out and play. This is a redundancy of activity, and this also has to be identified in class. It will be like whether once the drawing is completed by mechanical team, they will be sending it to the civil team, and they will be working in the same file, but all the file will be located in a cloud service, so that whenever there is an update by civil or electrical team, it will be indicated to the mechanical team, and everything will be integrated in cloud, so that there will be proper coordination between different teams for review and all the activities. And some of the in-house developments and automations. This is a okay. Now we have seen some of the BIM awareness, and also how some of the applications of BIM in water industry, where I have shown some of the examples. And other examples, other applications, I have not discussed, because there is because due to the restriction of data sharing and those things, I have discussed only few of the applications. And coming to some of the automations which and in-house developments which we have done in BIM, here this is a parametric modeling, is an in-house developed tool. Here we are using we are creating all the pump houses of different projects of irrigation looks similar, and all the components here like ESR tank and everything will be similar to one another, except for some dimensions and some small variations. But all the tanks and everything will be similar to each other. So for that reason, we are creating a parametric model where only the dimensions will be changed, and it will be utilized in every places, instead of developing the model from scratch for each and every model. We are using a parametric model which will eliminate the need for redraws, and all the there will be a quick extraction of GA models and everything. All the redraw and reworks will be eliminated here. That is what called a parametric modeling. Then, as I told, common data environment and automations in BIM tasks. We are using all the visual programming tool Dynamo and Python for automating automating more repetitive tasks and everything, like deletion of unused views. In BIM model, if there are some views which are if you are increasing the views, automatically the size of the BIM model will increase, size of the BIM file will increase. Revit file will increase. Then the file cannot be, sometimes when it exceeds the limit of the size, then it cannot be opened in Revit software. So there comes the need for deletion of unused views. So we have created a Python Dynamo model, including with Python programming, where it will be automatically deleting all the unused views and everything. And some automated I will go in the flow, I will show you the automations. And for cable routing also, I will show you in detail in further slides. And scan to BIM, in one of our project, we had it is a brownfield project where there is already a pump, where there is already a treatment plant located, and we have to further improve the treatment plant and further expand the scope, expand the capacity of the treatment plant. So here, when we asked the client for detailed drawing and everything, they told that there is no drawing available and there is no proper documentation available. So we went with the iPad, and in iPad there is a LiDAR technology where you can scan scan the building, and that whole building will be recorded in as a point clouds, and then it can be used, developed in a BIM model, and it can be used for further expansion and all the things, like all other applications. And this was appreciated by the client, because even when you are using iPad and going into the building, you can even record the places which cannot be measured, or which is inaccessible. Also, some ducts were inaccessible, but those also we can record using the iPad, and it was also developed in the 3D model. That is how it was so much useful. This scan to BIM technology was and this is one of the automation tool which we have developed. Once the stat pro model, for analyzing the data, you have to develop all the elements in the stat pro model, and then you have to develop. Then once the analyzing of data is completed and the sizes of beams and everything is finalized, then you have to develop the model in Revit again using those sizes and everything. This is how there was a redundancy in task. First this model was then again developed in here, again there was a rework and everything. So we have developed an tool in-house using the Python and Dynamo, where once the StatPro model is fed into the tool, it will automatically give the Revit model. This was even applied in one of our project, and it was more successful, and we were getting an accurate Revit model as per the stat model as an output. And some of the automations in using visual programming in Python. This is an automated pile, column, and coordinated extraction, where the pile coordinates, coordinates of the pile columns will not be the feeding. Actually, it is more required because you have to locate exactly in the site where that pile column has to come. All this you have to record exactly as per the coordinates. But while creating the model, it will not be automatically updated. You have to check for all each and every coordinates, and then you have to update it manually to reduce this redundancy in work. We have developed a model, Python model, where once you select the component and run the model, it will automatically fetch the coordinates and it will update in the attributes table. And this is automated model checker, where there are different where it checks for all redundancy of develop like redundancy of models, where two staircases or two slabs or two equipments have been modeled and kept. Those inaccuracies and those repetitions will be checked by this model checker, which is also developed using Dynamo and Python, and it will automatically give you the output. These are all the redundancies in data, and this can be deleted by this can be selected and deleted. This is how most, or else you have to manually check whether there is two models located, or in each and every element you have to check manually. But this reduces that, and it makes it more automated. Then automated constraints removal. Some places there are some constraints, like you cannot move this wall or move this due to some constraints, and those constraints, when you want to remove it, you can run this model, and you can then all the constraints will be removed automatically, and there is no manual intervention required here. And now let's go with case studies in BIM application. Like I have given the case study of two projects, Dolera and also Amala Utilities project. And Dolera project, here is the BIM model of CETP, Common Effluent Treatment Plant, and Sewage Treatment Plant. This is a sewage treatment plant, and this is Common Effluent Treatment Plant. And one of the main aspect of BIM execution plan here was one of the main aspect of this one of the main implication of this project was the client has mandated a BIM execution plan, which normally clients don't do in most of the irrigation projects. But here we were mandated to provide the BIM execution plan. A BIM execution plan is a document which standardizes all the flow from modeling what LOD you have to provide, what class deduction, and how the flow has to be defined, and even the risk matrix, responsibility matrix, and what LODs you have to provide for each and every element, clash matrix, what softwares to be used. Everything will be provided in BIM execution plan and submitted to client at the starting of the project itself. And that is a standard which to be followed throughout the project. That is called BIM execution plan. And an example of the BIM execution workflow we have designed here, we have provided in this BIM execution plan is first we have to go for design authoring of developments, and then structural analysis of all the structures using different softwares, sewer gems, water gems, and stat softwares. Everything we will be using to do the structural analysis. And then 3D coordination for class detection, developing the 3D models and doing the class detection. Then 4D modeling using the Navisworks software and everything. And finally, recording the as-built data. This is how the BIM has to be taken place in this project. That is what given by that is what submitted in BIM execution plan, and that was done in the project. And this is an advanced cable. Actually, the video is not playing. Okay. This is a cable routing problem. There was crossings. These are all crossings. Uh, Sorry, wait just a minute. Actually, a cable has to pass through this crossings in Dolera project, and this is a road going here, and this is a road going here, and there is a road crossing here, and the cables has to be passed through these crossings. But whereas there is a minimum bending radius for a cable to pass through, or else the cable cannot bend. Based on the diameter of the cable cannot bend this much, and there is a minimum bending radius that should be followed. But whereas in the 2D drawings, that minimum bending radius were not been considered, and all the drawings has been submitted and client approved, then the site people found out that there is a problem in bending radius, and you cannot bend the pipe and bend the cable and take it through. Then we taken it into BIM model, and we have developed a model where it will automatically calculate based on the radius. It will automatically calculate the bending radius, and based on that it will model the ducts at what height it should be located and everything. This was completely automated. This process was completely automated. Sorry. This process was completely automated, and you can see how the cables has be taken based on the diameters. The cable will be routed here, and due to time constraint, I am running the video fast. And for rebar modeling in Amala project, whole rebar modeling was done in separately using BIM model, and the fabrication drawings, when even when taken into the rebar drawing, then they found that some of the shear keys were missing, and that will be that when executed in site will create a rework and everything. So that is why a BIM should be mandated in each and every project. With the BIM model itself, they identified that shear keys and the holes provided in fabrication, like in the fabricated walls, were not matching to each other. So accordingly, it was revised during the design stage itself, and all the reworks were avoided. And bar bending schedule can also be extracted automatically. And now comes the GIS BIM integration. This is an integration of two technologies: GIS and separate technology, and BIM is a separate technology. Both integrated together will bring out more, because nowadays client are expecting more visualization and more advantage in the processes. BIM, generally it is used for design and building, although it is used in whole life cycle. Main application to when comes to a project life cycle, it is mandatory that whole GIS and BAM has to be integrated together. This arises the need for BAM GIS integration, which is with the increased portability of geospatial data and intelligent digital models for above ground below ground infrastructure like pipelines, those things. It improves the safety and also speed of construction and maintenance. We will see in the key concepts of BIM GIS integration. GIS is a software where the collection, analysis, and visualization of all the data is oriented with the geographical location and spatial location, like spatially how much height it is located, and geographically where it is located. Everything is recorded in GIS platform. And BAM is a digital representation of the physical model, and functional representation also. BAM focuses on the internal details of structures, whereas GIS focuses on exact geographical location of the structure. So both BIM and GIS, when integrated, creates better decision making tool, and also it supports in better project planning. where how the site is located and everything will be, you can see in this. And data interoperability. Two datas where BIM is a different data, different technology, and JS in different data and different technology. Both interoperably will give an holistic view. And requirement of significant processing power and advanced software capabilities. BIM-JS integration requires more processing power because BIM already is a big model, and JS again is an heavy data. So integrating both will provide a more requires a more software capabilities and more processing power. And these are the applications of BIM JS integration: urban planning, infrastructure management, and disaster risk management. As I told you, BIM is in design and build stage, where build, commissioning, designing, project planning all will be taken care by BIM. And whereas GIS, when integrated, takes care of asset management, monitoring, master planning, regulation. Like regulation and permitting, we will be using GIS for forest clearance, and this marine clearance, coastal clearance, everything we will be using GIS. And for master planning of the whole location, we'll be using GIS. And also at the end of the project, during the operating stage, for asset management, monitoring, everything, we will be using GIS. And this is a sample output of how BIM models. These are all BIM models. This pipe is a BIM model, and this is a GIS platform, where the BIM models are taken into GIS platform, and how it is visualized and how it will be placed in the location. Everything you can see here. And the necessity of BIM GIS integration is that it provides a one-stop solution, and it gives an enhanced visualization. I will show you there are some videos, you can see that how visualization will be enhanced when using BIM GIS integration integrated model. And integration of assets geographically. In BIM model, it is not. It will be like the model will be located. It will be like only the model you can see there. But whereas when it is integrated with BIM and JS, you can actually see the model where it will come, and see how the terrain properties are. And based on that, you can do all the planning for all the construction activities. And streamlined workflows and improved collaboration. Better collaboration can be enhanced using the GIS BIM integration. And digital twin. This is the most recent technological advancement in civil engineering division, where you are using a exact model of the constructed building. It will be available in digital. And and whatever changes will happen here will also be reflected in the digital model, and you can directly monitor the building using the digital model. This is digital twin. And the research area is open now, and there are many research outcomes coming from digital twin. And challenges, in some of the challenges in GIS BIM integration is data interoperability. As I told you earlier, the GIS use shapefile formats, and whereas BIM uses all IFC and Revit files. So these two are different data formats. When they are to be integrated together in one platform, there comes the interoperability problems. And also scale and detail. GIS provides a vast area and gives small level of detailing. But whereas BIM model
Oh my god. Oh my god. It was not.
But whereas BIM model takes a small area and provides more and more detailing of that building. That is that scale and detailing. When integrated into the GIS model, you will see that even the BIM model looks small because of the scale which we are using the GIS. And also coordinate systems. BIM model is generally designed with what is the project coordinates or local coordinates, but GIS is with global coordinates. It is with UTM levels or those things which are all global coordinate systems. So integrating both the systems, coordinate systems together, will also be a challenging scenario. And data management and storage. Yeah, as I told you earlier, BIM is a huge model, GIS is a huge model. Both will have a huge volume, and integrating that increases the volume. And the volume of data stored in the model is huge, so that even the software, even the system capability is most required. Only high-end softwares, sorry, high-end workstation systems can open the BIM-JS model. And normal with 2 GB, 3 GB, 4 GB RAMs, you cannot even open a BIM-JS model. And software compatibility. Specialized software is earlier there were many requirements for specialized software to open the BIM-JS integrated model, but nowadays even RGAS, and also sorry, RGS is a software, and QGIS, all the softwares now have the compatibility to open BIM-GIS model. And input matrix for BIM-GIS model, you have to provide all the inputs in different and the desired formats for inputs you can see here. With this itself, you can get an idea that different formats of files are integrated into one common platform to provide a GIS BIM integration. That is how complex this integration will be. And you can see the building structures and pipeline will be in AutoCAD or Revit format, and the terrain satellite imagery, all the imageries will be in the DEM or contour format, or in LiDAR, LAS files, ortho images, these formats. And pipelines in this is in with the aspect to that water project. And pipeline and topological boundaries will be in shapefile or CAD formats, whereas design drawings, site images, approvals, all these documents will be in Word and PDF. This all are integrated into one platform to provide an holistic view of the model. And Revit to GDB. Revit files are, this is a common methodology followed in RGAS software, because we are using RGAS software in L&T construction. So this is the methodology which we are following in RGAS software to bring in the Revit model, that is a BIM model, into that GIS platform. Revit files are first opened using BIM file to geodatabase tool, and then all the future data sets are to be defined, and each and every layer is to be created, and that is how whole model is brought here. This is somewhat more complex methodology which cannot be understood just by this flow chart. You only with experience you can understand the methodology. And the data interoperability between Revit and GIS. And in Revit file, you all know what is discipline, what is category, what is family, and what is type. For example, the discipline, that is the architectural or mechanical mm, or electrical, this discipline in BIM file is called as feature data set in RGS BIM workspace, like RGS workspace. It is called as feature data set. And whereas the doors, windows, these categories are called as feature classes in RGS. And whereas different types of doors like double glass, single flush, which are called as family in BIM file, is called as attribute in GIS database. And also the sizes, which is called as type in BIM file, is called as an attribute in GIS database. So this is how visualization will look. Visualization and manipulation of whole 3D models, and you can see this in multi-scale views. You can even zoom in, zoom out, you can go walk through inside everything. And also here you are seeing a sectional view, and you can also create a section and section in between the building, and you can even view that also. So visualization is more enhanced in BIM-GIS integrated platform. And this is a model where you can even differentiate the climate, in rainy season how it will look, in snow season how it will look, during winds how it will look. Everything you can visualize here, and you can show it to client so that they will be impressed on this technology. And BIM and GIS platform attributes, and how, for example, this is a shutter door. And the shutter door, all the parameters which you are loading in BIM model will also be reflected in GIS model as attributes. You can see detailed attribute will be here. And also you can also even to add custom attributes. You can even define some attributes, and you can add those attributes also. So it can be both defined and also custom inputted. This is lidar survey as terrain. So lidar survey, like Hussein Babu sir would have explained what is lidar survey. That lidar survey output is taken as the terrain model for that GIS platform. And you can see BIM model of the pipe is input, like is taken into that GIS platform. And you can see how that pipe will go below that river, and how it will come again above the river. And this is how this will be only visualized using BIM GIS integration. Only with integration you can see how because all this depths will be already given in BIM model. But in BIM model you cannot visualize whether a river is passing here, or a railway line is passing here, or anything. You cannot identify what is the passing here. But in whereas in when it is taken into GIS platform, you can visualize even that also. All the topography features like roads, streams, wells, trees, etc., all are converted here, and it is done. It is visualized here. See here, this is a 3D visualization of the terrain model, of the LiDAR model. The LiDAR imagery is taken into GIS platform, and you can see how the water will be. These are all buildings, and this is a dam. Even the dam you can see as 3D model here. Um, so everything is recorded, and it is in GIS platform. You can see it in 3D, and 3D in pipeline. Even the pipeline data which we are taken from CAD drawing is converted into 3D pipeline in GIS. This is something like Hussein would have explained what is chuck. Chuck is in irrigation, it is a parcel of land, and more chucks combined together, we will be giving the pipeline routing, how it will be going through that. So all this can be visualized in GIS. This is a GIS platform, and we have hosted the files of chuck planning, cadastral maps, and everything here. Even the boundaries of villages, everything we have hosted here, and we can visualize this in the GIS platform. And some of the case studies for going through will be some of the videos of BIM-JS integration. This is a video of Parvati, a project where we have done the BIM-JS integration. You can see this is a BIM model. Um, this is a BIM model, and this is a BIM model of that delivery chamber and the pipeline, and the terrain model which we acquired from the LiDAR scanning data, that is that is taken into the GIS platform, and also the BIM model is taken into the GIS platform, and now both are visualized together as how the pipe will flow and how it will flow through the river and through the lands, where in which areas it will flow. Everything can be visualized here. This video alone I will play completely. Other videos we can go through in fast manner. And this is pump house 2. This is pump house 2 is also modeled. This is a BIM model. You can go inside also and see what are all the pumps located and how people can stay there. Will there be clearance of walking for people to walk and everything here? Also can be visualized in GIS. This is another pump house. Now we can see this vast dense network of pipes is visualized in GIS platform. This is completely modeled in BIM and taken into GIS platform, and you can see the whole network of pipe, how it will be, it will go, and how you should be, at what locations you should lay the pipe. And everything you can see here. Model will be, sorry, this is another project, Lower Sutkal project. This is also an irrigation project where pump house is modeled. This is a electric substation providing the electricity required for pump house. And you can, this is the reservoir where the water is collected and pumped to the whole location. You can see this is the outlet box. These are all the distribution network at the end stage, where the outlet box will record to whom how much water should be given. Everything will be recorded inside this outlet box, and that data will be transferred to the pump house. This is how even BIM-JS is used for asset management also. This is an Dolera SCTP where the BIM model is bought into GIS platform, and you can see where it is. You can visualize where it is located, and you can go inside, come outside. You can see everything, all the data is here. And this is for an sewage treatment project where you can see the pipeline, how it is crossing, and how manholes at what depth it should be buried and placed inside. Even that also you can visualize. These are all sewage collection pipes, and it is taken to the pump house. This is the pump house, which is it is taken to the treatment plant. This is the treatment plant, and the sewage water is treated there. and this is a network of sewage collection. And you could have seen in various in Chennai, you can see in the streets there are many manholes like this. Those manholes are all either at stormwater drains or sewage collection drains. So this is how the BIM-JS integration will help in visualizing the BIM, visualizing how the network will go through. Till the existing STP, sewage treatment plant. And web-based application, the BIM-JS integrated model is hosted in the web-based application in the web, and you can in the web with just an link. This is an you can see here, it is an HTML link. It is a link to a web page. You can just log into that web page using the ArcGIS login credentials, and you can see this BIM-JS integrated. You does not require any software or anything like that. Before, I told you that before there was a requirement for a software to open this, and even a 2 GB, 4 GB RAM systems cannot open BIM-JS. But this will be but whereas in web, when it is hosted in web application, the main file will be located in some other server, in the server location, and it will be showing you only that only the output line, so that all the processing will be taking place in server location only. So this link can be opened even by small and laptops and everything, and you can visualize the BIM-JS model. And cloud-based collaboration, GeoBIM is an application of of ESRI, where you can integrate the BIM-JS in model, and you can see the BIM model separately and JS model separately, and even both integrated together also you can see here. And asset information, as I told you earlier, all the asset information will be recorded in BIM-JS. A VR capability, BIM-JS has the capability of VR walkthrough also. Just you can once the model is hosted in a VR software, you can even, these are all the locations. You can just click on the location, and it will be showing you how like it will be automatically taking you to that location, and you can wear the VR glasses and just turn around and see how that location will be. All those, actually, due to data security reasons, I couldn't show you the video of VR capability, but this is how VR is also possible with BIM-JS integration. And some of the benefits of integration. This will be the last slide for BIM-JS. Benefits of integration is like advancing the understanding of projects. You can see that the projects earlier, they don't know how that field will be. Will there be any ridges or anything? But with the BIM-JS integration, before construction itself, you can see how the how the building will come up, and those locations also you can understand before in hand itself. And collaborative workflows, you can see and there is informed decision making. For decision making also, it is more useful, and for data and documents in single environment. I told you all those things. It will be taken into one particular environment, where you can even see the data and even the approved documents, and what is the data, what is the attributes, and everything will be shown in that single environment. And also the infrastructure assets can be better viewed in relation to the geographic location, like geographic location, and in this location how that infrastructure will be there, and everything you can see. That is some of the benefits of integration. Okay, with that presentation over, and these are some of the journal and conference publications which our team, we with the BIM-JS integration and everything, we have provided, we have submitted papers in various. And also before Hussein Babu sir and Bhuvanesh sir has explained some methodologies, those are also we have submitted papers, and these are some of our journal papers which you can refer to. And this is some of the glimpse, and these are some of the awards, both the internal L&T construction awards and external awards, which we have won based on our solutions which we are providing to site. And these are some of the glimpse of the awards and recognitions which we have which we have secured. And coming to campus recruitment, L&T takes GETs and PGETs. GETs are those who are completed bachelors in engineering. There are various opportunities in L&T construction. Once they come as a campus recruitment, they will take you as either as a GET or postgraduate engineer trainees, or those who have completed masters. These are just a glimpse of some departments where you are taking there, but there are lots of departments where we will be recruiting candidates. And this is Build India scholarship, which many students will not be aware of. This is Build India scholarship. It is apart from campus recruitment. Each and every a final year student of pursuing BE from core engineer, civil engineering and electrical engineering are eligible to apply in this BA scholarship. 2 years you will be doing the full-time MTech degree in construction technology and management in either IIT Madras, IIT Delhi, Surathkal or NIT Tiruchi, and it is a 2-year course completely sponsored by L&T. L&T will be sponsoring you the entire program, and they will be even providing you stipend during the program. And you will be on completion of this MTech degree, you will be successfully placed in the call in job role. And this is eligible only for the final year students who are pursuing BE BTech in civil engineering, core electrical engineering. This applications will be open during January. Maybe I think I am not sure whether it is open now or not. You can just type in Build India Scholarship L&T Construction, and you can check whether the application is open, and you can apply for this if you are a final year student of BE Civil or Electrical Engineering. And thank you.